Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss circles. In this chapter, we are going to discuss the sums in the exercise 10.5, page number 184 in the textbook. In the previous class, we have discussed the angle subtended by an arc of a circle and the points related to that point. And we have defined cyclic quadrilaterals, and the properties of cyclic quadrilaterals. I hope you have understood that concepts well. You have learnt the concepts well. Haven't you, my dear children? Right. Now come to the question number 1 in the exercise 10.5. Are you ready to listen the class? Right. In the adjacent figure, A, B and C are 3 points on a circle with the center O, such that angle BOC is equal to 30 degrees and angle AOB is equal to 60 degrees. If D is a point on the circle with the other than the arc ABC, find angle ADC. See, observe this figure, my children. This is a circle with the center O, and it is given that angle AOB is equal to 60 degrees, angle BOC is equal to 30 degrees. Then we have to find angle ADC. Okay, my children. So we connect the previous knowledge, whatever you have learnt in the previous class, the angle subtended by an arc of a circle. The angle subtended by an arc of a circle at the center is double the angle subtended by the arc at any point on the remaining point of the circle. Do you remember that point, my children? Right. So here this arc AC is subtending angle AOC at the center of the circle. Yes or no, my children? So let us find angle AOC by adding these two. What will get to angle AOB plus angle BOC is equal to 60 degrees plus 30 degrees. Okay, my children. Now observe this figure. What is the angle AOB plus angle BOC? Angle AOC. Yes or no, my children? Angle AOC is equal to 90 degrees. Understood this step, my children? Right. So this angle AOC is angle subtended by arc AC at the center of the circle. Yes or no, my children? The point D is on the circle other than this arc. Yes or no, my children? So angle AOD, angle ADC, angle ADC is equal to half of angle AOC, because the angle the angle the angle subtended by an arc at the center of a circle is double the angle subtended by it at any point on the remaining part of the circle. Remaining part of the circle. Do you remember this point mentioned on the angle subtended by an arc at the center of the circle is double the angle subtended by it at any point on the remaining part of the circle. By using this property, we have written this step. Understood this step, my children? Right. That is equal to 1 by 2 into, we have already found angle AOC. What is angle AOC here? 90 degrees. Yes or no, my children? So, 2 ones to 45 times. That is equal to 45 degrees. Understood, my children? Right. Now come to the question number 2. Next question. A chord of a circle is equal to the radius of the circle. Okay, my children, understood? Find the angle subtended by the chord at a point on the minor arc and also at the point on the major arc. Understood, my dear children? Understood this question? Right. Now let us draw a rough diagram for this given data. Okay, my dear children? Right. Let us take a circle. Let us take a circle with the center O. Let us consider this is the radius of the circle. Okay, my children. Let us take an arc. Let us take a chord of length radius. The length of this chord is also same as that of radius of the circle. Okay, my children, understood this one? Now, let us join these 2 points. If you observe this one, this is a equilateral triangle. Yes or no, my children? It is an equilateral triangle because here the length is r, the length is r. This is also length r because chord of a circle is of length radius of the circle. Yes or no, my children? Right. So this is a arc AB. Now we have to find the angle subtended by the chord. Now this is chord. The subtended by the chord at a point on the minor arc. This is a minor arc. Yes or no, my children? And this is a major arc. Yes or no, my children? Let us take point C on the major arc. Let us join AC and BC. Similarly, join AD and BD. Okay, my children. Like this, we have drawn the rough diagram for the given data. Okay, my children. Right. Let us write the description of this figure. In the adjacent figure, let O be the center of the circle. Let O be the center of the circle. OA and OB are radii of the circle. AB is a chord. AB is a chord. A chord with length equal to radius of the circle. Okay, my children. In this adjacent figure, we are writing the description of this figure. Let O be the center of the circle. OA and OB are radii of the circle. AB is a chord of the circle with length equal to radius of the circle. Okay, my children. Right. Therefore, OA is equal to OB is equal to AB. Okay, my children. Now construction. let us take point C on the circle. Let us C and D be 2 points on either side of this chord. Okay, my dear children. Let C and D 2 points on either side of the chord and are lying on the circle. These are the 2 points we have taken on either side of this chord. This is above and this is below the chord AB. And these 2 points are lying on the circle. Understood this point, my dear children? Right. Now construction. Join OA, OB, AC, BC, AD and BD. We have joined all these points. Okay, my dear children. Now triangle OAB is an equilateral triangle. Yes or no, my dear children? Triangle AOB is an equilateral triangle because OA is equal to OB is equal to AB. We have written this sentence here clearly. Yes or no, my children? Therefore, it is an equilateral triangle. Therefore, angle AOB is equal to 60 degrees. Yes or no, my children? This is angle 60 degrees. Okay, my children? Right. Now, here we have taken the point C on the major arc of this circle. Okay, my children. C is lying on the major arc of the circle. Let us find the angle ACB. Angle ACB is equal to. Therefore, angle ACB is equal to half of angle AOB. Half of angle AOB. Because the angle the angle subtended by an arc of the circle, is double the angle subtended by it. Subtended by it at any point on the remaining part of the circle. We have learned this point because of this property. The angle subtended by an arc of the circle is double the angle subtended by it at any point on the remaining part of the circle. Okay, my children. By using this point, we have written this step. Understood this step, my children? Right. that is equal to 1 by 2 into 60, that is equal to 1 times 2 30 times. So 30 degrees. Therefore, angle ACB is equal to 30 degrees. So we have found the angle on the major, the angle subtended by this chord at any point on the major arc. Yes or no, my children? This point is lying on the major arc. Now let us find the angle subtended by this chord AB at any point on the minor arc of this circle, means D, at D. Let us find angle ADB. Okay, my dear children. So this is 30 degrees. That is 30 degrees. Okay, my dear children, understood this point? Right. Now, if you observe ADBC, this is a cyclic quadrilateral because the vertices of all these vertices of this quadrilateral lying on the circle. Yes or no, my dear children? Here, all the vertices, all the vertices ADBC are lying on the circle. Okay, my children. So all the vertices of quadrilateral ADBC are lying or on a circle. This implies ADBC. ADBC is a cyclic quadrilateral. Okay, my children, understood this point. Here, all the vertices of this quadrilateral ADBC on a circle. That is why this quadrilateral ADBC is said to be a cyclic quadrilateral. Immediately, we have to recollect, bring back that knowledge into your mind. The properties of a cyclic quadrilateral. What is the properties of a cyclic quadrilateral? The sum of either pairs of opposite angles, the sum of either pairs of opposite angles of a cyclic quadrilateral is 90 degrees. Yes or no, my children? Yes. Therefore, angle ACB plus angle ADB, these two angles are opposite angles of this quadrilateral ADBC. Okay, my children, that is equal to 180 degrees because the sum of either pair of angles, either pair of angles, pair of either pair of opposite angles, either pair of opposite angles either pair of opposite angles of a cyclic quadrilateral okay, my children, by using this property, the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. By using this property, we have written this step. Understood this step, my children? Right. So in this equation, we have already found angle ACB, that is 30 degrees. Yes or no, my children? So let us substitute that value. 30 degrees plus angle ADB is equal to 180 degrees. Understood this step, my children? Because angle ACB is equal to 30 degrees. We have already found. From this equation, we find angle ADB. By transposing this 30 degrees to RHS, But then what you get? Angle ADB is equal to 180 degrees minus 30 degrees. Understood this step, my children? Right. That implies angle ADB is equal to 150 degrees. Understood, my children? Right. Here I am not explaining question number 3. Please try the question number 3 yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Will you try the question number 3 yourself? Right. Now come to the question number 4. In figure, angle ABC is equal to 69 degrees. Angle ACB is equal to 31 degrees. Find angle BDC. Understood this question, my children? Observe this figure carefully, my children. This is angle ABC, that is 69 degrees. Angle ACB, that is equal to 31 degrees, are given. We have to find angle BDC. Okay, my children? Right. Now, let us write the given data. Come to the solution part. Given in the adjacent figure, given angle ABC is equal to 69 degrees and angle ACB is equal to 31 degrees. Okay, my children, these are given for us. Now let us find angle BAC in the triangle ABC. In triangle ABC, triangle BAC plus angle ABC plus angle ACB is equal to 180 degrees. Angle sum property. Angle sum Okay, my children, by using this angle sum property of a triangle, we have written this step. Understood this step, my children? Right. This implies we don't know angle BAC. We don't know the measurement of angle BAC. So we write angle BAC plus angle ABC. It is given 69 degrees plus angle ACB. It is 31 degrees is equal to 180 degrees. Okay, my children, understood this step? Right. This implies angle BAC plus what we'll get here? Sum of these two numbers 100 degrees is equal to 180 degrees. Understood this step, my children? Right. Angle BAC is equal to, we are transposing plus 100 to RHS, then it becomes minus 100. Okay, my children? So 180 degrees minus 100 degrees. This implies angle BAC is equal to 80 degrees. Understood this step, my children? Angle BAC is equal to 80 degrees. We got here 80 degrees. Now if you observe, this is a BC, a chord of this circle. This chord is dividing this circle into two segments. As for the children, this is a minor segment and this is a major segment. We know that there is a property. The angles in the same segment are equal. Do you remember that point, my children? Angle BAC and angle BDC are the angles. They are the angles in the same segment, minor segment. As for my children, angle AB, angle BAC and angle BDC are the angles in the same segment. These two angles are in the same segment. Therefore, we know that angle BDC is equal to angle BAC, because angles in the same segment segment of a circle are equal. Angles in the same segment of a circle are equal. By using this property, we wrote this step. Understood this step, my children? Right. This implies angle BDC is equal to, we have already found angle BAC, that is 80 degrees. Understood, my children? Right. Now come to the question number 5. In the adjacent figure, A, B, C and D are 4 points on a circle. Observe this figure, my children. A, B, C and D. All these 4 points are on a circle. AC and BD intersect at a point E such that angle BEC is equal to 130 degrees and angle ECD is equal to 20 degrees. Observe this figure, my children. Angle BEC, this angle is 130 degrees. Angle ECD is equal to 120 degrees. These are given to us. Then we have to find angle BAC. We have to find angle BAC, this angle. Okay, my children, understood this point? Right. Now come to the solution part. Okay, my children. Right. In the adjacent figure, given the points A, B, C and D are on a circle. And BEC is equal to 130 degrees. Let us write this data completely. AC and BD intersect at a point E such that angle BEC is equal to 130 degrees and angle ECD is equal to 20 degrees. Just I wrote the given data in these 4 lines. Okay, my children, understood this? These 4 lines, right? If you observe angle BEC and angle CED, these two angles form a linear pair. Yes or no, my children? Angle BEC plus angle CED plus angle BEC is equal to 180 degrees, because linear pair axiom. By using the linear pair axiom, these two angles form a linear pair. That is why we wrote this step. Understood this step, my children? Right. This implies angle CED. We don't know the measurement of angle CED, but angle BEC. What is the measurement of angle BEC? 130 degrees is equal to 180 degrees. Understood this step, my children? Right. From this equation, we find angle CED by transposing 130 degrees to RHS. Then it becomes minus 130. Angle CED is equal to 180 degrees minus 130 degrees. Understood this step, my children? Right. This implies angle CED is equal to 180 minus 130 degrees. That is 50 degrees. Understood this statement is run. Angle CED is equal to 50 degrees. Here we got this angle is 50 degrees. Now come to the triangle DEC. DEC. In the triangle DEC, in triangle DEC, angle EDC plus angle DEC plus angle ECD is equal to 180. This is the angle sum property of a triangle. By using this angle sum property of a triangle, we wrote this step. The sum of these three angles equal to 180 degrees. The sum of the angles of triangle DEC is equal to 180 degrees. Understood this step, my children? Right. This implies angle EDC, we don't know measurement of this angle EDC, we don't know this one. Plus angle DEC, what is angle DEC? 50 degrees. Plus angle CED, 20 degrees, is equal to 180 degrees. Understood this step, my children? We substituted angle DEC and angle ECD from this figure. Okay, my children? Right. This implies angle EDC plus 70 degrees is equal to 180 degrees. 50 degrees plus 20 degrees. What will you get here? 70 degrees. Understood this step, my children? Right. From this equation, we find angle EDC, that is equal to 180 degrees minus 70 degrees. Then what will you get? 180 degrees minus 70 degrees, 110 degrees. So this is angle EDC. This angle EDC is 110 degrees. Yes, sir, my children. Now, if you observe angle BAC and angle BDC, these two angles are in the same segment. Yes, sir, my children. BC, the chord BC is dividing this circle into two segments. This is one segment and down is another segment. So these two angles are said to be angles in the same segment. Yes or no, my children? Angle BAC and angle EDC are angles in the same segment. We know the property. Angles in the same segment of a circle are equal. This implies angle BAC is equal to angle EDC. We have found angle EDC value, that is 110 degrees. So this is angle BAC because angles in the same segment, angles in the same segment of a circle are equal. So by using this property, we wrote this step. This is already asked. This is asked angle BAC, that is 110 degrees. Understood, my dear children? Right. You please try the remaining questions in this exercise yourself, my dear children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right.